All right, in this video we're going to talk about graphing rational functions. So I have up here, the 5 basic steps or the 5 things we need to do in order to be able to sketch the graph of a rational function. So we'll talk about those real quick, and then I'll actually do an example where we do all these things and then draw the graph. All right, so first thing, factor the numerator and denominator if they can be factored. It'll just make it easier to do these other things that we have to do if you factor the numerator and denominator up front in the beginning. Right, and then next thing, find the intercepts. To find the X-intercept, you set your numerator equal to 0 and you solve. Right, to find your Y-intercept, you plug in x equals 0 and then see what y is equal to. Right, so and as we go through the actual example, I'll explain these things in a little more detail of why we do this and how it works and stuff like that. So that's finding the intercepts. The vertical asymptotes, we want to find the vertical asymptotes. So if you did not watch the video that I did on finding the horizontal and vertical asymptotes, you should check that out because I kind of explained how we find the asymptotes, both the vertical and the horizontal. And we also did an example where we just did that. So if you haven't seen that video yet, you might want to check that one out. But we find the vertical asymptotes. We also test on either side of the asymptote to see, is the graph going towards positive infinity on that side or is it going towards negative infinity? All right. Step 4, we find the horizontal asymptote of the graph, if it exists. And then step number 5, we sketch the graph of the function. Right, now, the order that you do these is not super important. Now, obviously, sketching the graph should be the last thing you do. You don't want to sketch the graph before you find all the information you need. That would be pretty stupid. But as far as like the intercepts, the vertical and horizontal asymptotes, the order that you do those is not important. You just have to do all of those things before you go ahead and sketch the graph. All right, so those are our basic steps. I'll put up the example here, and then we will, like I said, go through each of those steps and sketch the graph of a rational function. All right, so here's the example. We're going to graph r of x equals 2x squared plus 7x minus 4 over x squared plus x minus 2. All right, so when you have to graph a function, no matter what type of function it is, the first thing you should do probably is recognize what type of function you have. Rational functions are easy to recognize because it's a fraction, and you have polynomials in the numerator and denominator. So when you see, just a random math problem that says graph this function, if you see one that's like this with this fraction, you should know, okay, now I have to do all these things. I have to find the asymptotes and the intercepts, and I need to then use those to sketch the graph. All right, so first step is to factor the numerator and denominator. Right, so let's try to do that first, and I'll just try to do that up here so it doesn't take up too much space. All right, so let me do my denominator first because that looks easier, right? X squared plus x minus 2. I need two numbers that multiply to negative 2, add up to positive 1. That's going to be positive 2 and negative 1. Right? X plus 2, x minus 1. I'm just double checking to make sure that that's correct. Plus 2. Yeah, so that's good. All right, so there's my factoring of the denominator. For my numerator, a little bit more difficult. Let's see, I'm going to have a 2x and I'm going to have an x. And I need a 4 and a 7, so let me put a 4 here and a 1 there and make this a plus and make that a minus. It's going to be 2x squared plus 8x minus 1x, which is 7x, and then minus 4. Okay, that looks good. So I did that factoring real quick just to get it done so we can proceed with the rest of the problem. If you don't understand how I got from here to here, or if you had to do like some more work to figure out what the factors are, that's perfectly okay if you had to do more work than what I did. I factored so many things in my life that I can now just kind of look at these things and just kind of figure out how the factors are going to work out. But if you're not at that point yet, by all means do some more work on it. Now, if you can't figure out how I did that or how I got those factors, I did some videos on factoring, so you might want to check out those videos where I go through problems just like these, several of them, and explain very slowly how to actually do all those steps. But again, this is not a factoring video here. This is a video on graphing rational functions. So just to get that factoring out of the way quickly, I just kind of did it. All right. So we factor the numerator and denominator. Right. That's the first thing we want to do because at different points of this process, we're going to have to set the numerator equal to 0, set the denominator equal to 0. So if it's already factored, it's going to make it very easy for us to solve those if we factor it up front. Right. So you don't necessarily have to factor it in your first step, but it will make your life a little bit easier. All right, so that's factoring. Step number 2, we want to find the intercepts. All right, so I guess I can put a 1 up here. Right, factor the numerator and denominator. That's what we did up there. Step number 2 now, we want to find the intercepts. All right, let's do the X-intercept first. And again, it doesn't matter which one you do first or which one you do second. Right, to find my X-intercept, I set my numerator equal to 0. All right, why do I set my numerator equal to 0 to find the x-intercept? Well, if you recall, for any type of function, it doesn't matter whether it's a rational function or a linear or quadratic or anything. If I want to find the x-intercept, I set my y, or my whole function value, equal to 0, and then I solve for x. Well, that's really what I'm doing here. If I set my entire fraction equal to 0, well, what happens if I have to solve that for x? Well, I have a fraction here, so the first thing I want to do if I'm solving an equation that involves a fraction is multiply the denominator to the other side. But if the other side is a 0, when I multiply that denominator to the other side, 0 times anything is going to equal 0, and I'm left with just my numerator equal to 0. All right, so when we say find the x-intercept, and then we say just set the numerator equal to 0, we're just kind of taking a shortcut. Rather than set the whole function equal to 0 and then multiply that denominator over, we just kind of skip that step, because that step is going to happen the same every single time. Right? No matter what that denominator is, when I multiply it over times 0, it's going to equal 0, and I'm always just going to be left with numerator equal to 0. Right? So that just kind of saves us some time in that extra step of work. If we just directly set the numerator equal to 0. Now, if you forget that and you're not sure, if you just recall, well, for any x-intercept, I set y, or I set my whole function equal to 0, just go ahead and do that, and then do that extra step to solve it, and you'll get your x-intercepts, right? So it doesn't matter. This is, again, just like a little shortcut. All right, so I set my numerator equal to 0. Now, I already factored my numerator, so let me just go ahead and use that factored form. And this is what I was saying a couple minutes ago. You know, if you factor it in the beginning, well, then when you have to set your numerator equal to 0, it's already factored, and I just have to take each factor and set each one of those equal to 0. All right, so most of the work is already done for me if I do the factoring in the beginning. All right, so I have 2x minus 1 equals 0. I have x plus 4 equals 0. Right, whereas if I didn't factor, I would set this 2x squared plus 7x minus 4 equal to 0, and then I would have to factor it to get this, and then separate them, and then it's like an extra step of what I have to do. All right, so when I solve these, I'll add 1 over, and I'll get 2x equals 1, and then when I divide by 2, I get x equals 1/2, and then here, if I just subtract 4, I get x equals -4. All right, so I'm going to have 2 x-intercepts on this graph. All right, x equals 1/2 and x equals -4. All right, so there's my x-intercepts. I get those by setting y equal to 0, which for a rational function breaks down to just setting the numerator equal to 0. To get my y-intercept, I plug in x equals 0. Right? Again, for any type of function, it doesn't matter what type of function it is, if you want to find a y-intercept, you plug in x equals 0. All right, so when I plug in x equals 0, I'm actually going to go back to the unfactored form of my function, because that's actually going to be easier. All right, so my y is going to equal 2 times 0 squared plus 7 times 0 minus 4 over 0 squared plus 0 minus 2. And if you notice what happens, everything gets canceled out except for those constants at the end, the -4 over the -2, and -4 over -2 equals +2. All right, so my y-intercept is going to be at y equals +2. Right, so to find your y-intercept, you plug in x equals 0. Now, you could have also used the factored form to do that, but then you would have to multiply these. You would have -1 times 4, you would have 2 times -1, and you have that extra step where you have to multiply before you can simplify it. Whereas for the y-intercept, if you just plug the x equals 0s into the original form, all the x stuff goes away, and you just have those constants. All right, so a shortcut to finding the y-intercept for a rational function, just ignore all the x's, just take the 2 constants at the end, this one over that one, and that's going to give you your y-intercept for every rational function. All right, so I've got my x and y-intercepts. I filled up pretty much the whole board doing that. So I'm going to pause the recording and erase all this work, and I'll just put like the information over on the side, because we're going to need that when we actually draw the graph, and then I'll make some space for doing the next part of this. All right, so I put our intercept information up here so we can hold on to it for when we actually draw the graph of this function. Next up, we have to find the asymptotes, the vertical and the horizontal asymptotes. And the list I had up here before had the vertical asymptote first and then the horizontal asymptote. I'm actually going to do the horizontal asymptote before the vertical. The horizontal asymptote is quite a lot easier than the vertical asymptote. Finding the vertical asymptote actually takes kind of a lot of work to figure out which way the graph is going. So I'll save that for the last thing we do before we sketch the graph. Right, so next up, to find the horizontal asymptote is where we compare the degrees of the numerator and denominator. Right, and again, if you didn't watch the video that I did about how to find the horizontal and vertical asymptotes, you should check out that video where I describe in pretty good detail how to find the horizontal, how to find the vertical, what the rules are, what the procedures are. So horizontal asymptote, I compared the degrees of my numerator and denominator. So I have a 2x squared over an x squared, right? Remember, for the horizontal asymptote, I'm only concerned with those leading terms. And I compared the degrees. Well, they're both degree 2, right? So if the 2 degrees match, it's almost like they cancel each other out, and I then take the leading coefficients, which is 2 and then a 1x squared, so 2 over 1 gives me a horizontal asymptote at y equals 2. Right? Remember, there are other rules if your denominator has a higher degree or if your numerator has a higher degree. I pointed at the wrong things there, but if one of those degrees is higher than the other, then we have different rules for how to find the horizontal asymptote. So again, if you didn't watch the video on those rules, you should check that out so you know what those rules are. But here's our horizontal asymptote, y equals 2. Right? Same degree, I take the leading coefficients, 2 over 1, that gives me y equals 2. All right, I'm going to pause this again, write this up over on the side, and then I'm also going to get ready to do the vertical asymptotes. Alright, so I put our horizontal asymptote at y equals 2 over here. I also put up pretty much all the work for finding where the vertical asymptotes are. So if you recall, finding the vertical asymptotes, that's where our denominator is equal to 0. Right? And since we already factored everything over here in that very first step that we did, well, I just take that factored form, x plus 2 times x minus 1, set that equal to 0, then I can just right away separate the factors, set each of those equal to 0, and when I solve them, I get x equals -2 and x equals +1. Right? So this rational function, this graph, is going to have 2 vertical asymptotes, one at 1, the other at -2. Right? So remember, you're doing 2 different things, like setting things equal to 0. When you set the numerator equal to 0, that gives you your x-intercepts. When you set the denominator equal to 0, that gives you your vertical asymptotes. It's one of those things that sometimes people get confused on, but that's what you have to do to get the vertical asymptotes and then numerator for the x-intercepts. All right, so those are my vertical asymptotes, so I know where those are, but when I actually have to go and draw the graph of the function, I need to know, like on either side of x equals 1, is the graph going to go up towards positive infinity or down towards negative infinity? So now what I need to do is test points on either side of x equals 1 in order to figure out which direction the graph is going to go. Right, so let me kind of explain to you how to do this. And this is the part where doing one of these problems really becomes a struggle, and it's like a lot of work, and it can sometimes get confusing. So actually what I'm going to do here is I'm going to pause the video because we're starting to get short on time. I'm going to pause it and put up some of the work, and then I'll come back and explain the work that I actually have up here. Alright, so to test the vertical asymptote to see which direction the graph is going to go on either side, here's what we have to do. I pick a number a little bit to the left of x equals 1, so I pick x equals 0.9. That's going to tell me what's going on the left side of that asymptote. I pick a number a little bit bigger, x equals 1.1. That tells me what's going on the right side of the asymptote. And I plug those x values into the factored form of my function. Right, so 2 times 0.9, I won't read it all to you. So for each one of these x's up here, I put that 0.9. And then I just have to figure out, is each of those factors going to be positive or negative? Right, so this one's positive, this one's going to be positive, this one's positive, that one's going to be negative, right? Because 0.9 minus 1 is going to give me a negative value. And if I multiply a positive times a positive and then divide it by a positive times a negative, overall that's going to give me a negative number. And so on the left side of x equals 1, y is going to be approaching negative infinity. So as we approach that asymptote from the left side, the graph's going to go down. Now I'm going to do the same thing on the other side. On the right side, x equals 1.1, I plug that number into all the x's here, and I don't even have to calculate like 1.1 plus 4. I don't have to figure out that that's 5.1. I just have to figure out that that gives me a positive number. Right? So I get all positives here when I plug in 1.1, which gives a positive answer, which means y is going to approach positive infinity. So on the right side of that asymptote, the graph's going to go up towards positive infinity. So you see over here, I kind of drew the behavior near that asymptote at x equals 1. All right, I'm going to pause the video again because we're really short on time now. And I'm going to do the same thing for -2, and then I'll put it all together for the graph and come back and explain what's going on with that. So here I found the behavior for the other vertical asymptote, and then I put everything on the graph. So I have my x-intercepts at -4 and at 1/2. Right? I have my y-intercept at y equals 2. I have my horizontal asymptote y equals 2, vertical asymptotes at -2 and +1, and the behavior on either side of the asymptote, down on this side, up on this side, down and up. And then you just have to draw that graph to connect all those points and make them all fit together. Right? And you know what I'm going to do is I'm going to make another video now where I kind of explain in more detail how to find that behavior around the asymptote. So check out that video if you did not understand what I said.